Okay, hold on. I just need to. Yeah, I think this is fine. Is that too small? Yeah, too small. That's for display. Um, so, any of you guys know how you can like scale it so that it's normal size? Right now, it looks like it's like super. Just optimize.
No, this is.
Display when you go to the drop down.
Yeah, here.
Yeah, that's.
But then it's too small. Huh? If you click the drop down, building for display.
Oh.
Okay, cool.
Yes. Is that too small for there?
The focus is missing now, right? It's a bit blurry.
Yeah, it is.
It might be the.
It
Cool.
might be the cable. Yeah, it's much blurrier than before.
So let's see with
I
this.
guess it's unlikely that it's the focus of the beamer.
Yes,
Yeah,
exactly.
You kind of did lose some clarity.
Yes.
How about now?
It's okay. I would say.
Wait, try something else. If you go here, you have, I think, here settings about no color could also be for this display. No, that's not.
This is here. You know the FX tree.
No, it makes no difference.
Where you can network just to copy trades.
Why does this pop up? Where's the other?
Is it just
Yeah.
Copy all of his trades. If you trust him, that's how well he did in the last few years. You can break it down into individual stocks.
But is it? This is
I think it's the cable.
Oh no, it's actually stocks and crypto. Yeah, this crypto copy fund is crypto, but they have the
Let's see.
in the platforms.
So what I can do, I can like increase the size, like here.
It's like, why is it so blurry?
I can increase the size like that.
Yeah, sure.
I think they have the typical KYC, but I always skip them.
also Dutch.
Also Dutch. That's good.
So I always do that. It's like my address.
I think they require that's it, I think. I don't know, because I've gone through this KYC so many exchanges now that I forgot which one requires which specifics you know.
Check and see. This is the telephone number. Goes to the US.
Do you have your telephone with you?
Yeah.
So it should work.
I wonder how that's possible.
By your LinkedIn. System. By your LinkedIn.
Yes.
Sometimes it says it's connected, but it's just
It's not the best.
It's okay. We can do this. And So would the people from the which,
Can you show a screen with some code so I can see it?
yeah, sure. So I'm going to show this screen here.
Okay, I get it. That makes sense. Cool.
It's really small. Yeah, it's gonna be really small for. Okay. So people that are watching now, apologies. It's gonna be a little bit difficult to follow. On the coding side.
Because I have two. One is two instructions, which are terrible. That's my gymnastic very
All right. Are we ready?
We are.
Awesome. Welcome, everyone. Welcome the people that are on the web. So this is a talk that I'm going to give on creating your first smart contract, or maybe your second, your third, if you have already a little bit about it. It's going to be a very basic talk. Don't expect to become a engineer after this 55 minutes of excitement, but you're gonna come out of this, informed, and you're having a better idea what these smart contracts are, right? So first, let me tell you about myself. Like, you might be asking, who is this guy? So I'm Gustavo Guimaraes, and commonly known as Gus. I'm a software engineer. I've been working for many years in this field. Worked with many companies in the education, publishing, scientific research, and other industries. Last year, I started programming for the blockchain, and engage what this is all about. Rather than hearing a term like a jargon, a smart contract, here the one that for how to create token initial coin offering was seen like 3.5 thousand times. So there's a lot of.
Where was this at?
This is like a Medium. Yeah.
What is your handle in Medium?
It's the same one as my Twitter handle. This one. Gustavo Guim. So here. So a lot of interest right now in this space for crowdfunding, via the blockchain. So this is most of the work that I'm getting at the moment. And one thing that that's going to happen, that I'm foreseeing, is that these companies are raising money for their companies and for creating their products. Their products are going to be using smart contracts, are going to be done on the blockchain. So the demand for smart contract developer, blockchain engineers are just going to increase after here, right? If you want to learn about this is a great time to be in this field. Very new, just probably 2,000, a little over 2,000 smart contracts engineers that know what they're doing around the world. Yeah. So what are smart contracts? So this is a talk on what are smart contracts, and create your first one. So what are smart contracts? Anybody have a take on it? Self-executing contract? It's program, it's code.
It's a program on the blockchain.
Okay, yeah, it's it's pretty much it. It's just a program, right? Smart contract is like a fancy name that somebody coined.
Why do you call it smart contract? It's so
Yeah, it's a it is a fancy name for just a application, right? It's a program that instead of running on a server somewhere or like on the web, so this one is running on the blockchain, and the blockchain by its nature is a decentralized network, right? So if you have a copy on your computer, it's going to be the same one as on my computer and on his computer, and so on and so forth.
And
So
program is technical description, smart contract is business description.
I guess I could say that, yeah. Yep.
Is it okay if I just,
Yeah, please. We're here to all learn to share knowledge.
when I think of programs, I think of some programs that are, a few K and some that are gigabytes.
Mhm.
Is there a limit on the blockchain of how large a program can be?
No, there is a limit on computational power, right? It's basically how much gas or ether you're willing to spend for the computation that this program is gonna do, right? There's a limit for like every time that you run this program. There's a limit to like how many bytes you're gonna run it. And this is due to an incentive so that people don't spam the network, right? Because if it was free or too cheap, those that are against the idea of Ethereum blockchain could just like spam it and have these denial of service attacks. So that's the constraint you have, but not in terms of the program itself. You can create like a really large smart contract that does a lot of things, but it's just like only computational power that you're doing. Like if you're willing to pay like the gas, the money for that, you can do, yeah.
Wouldn't that like create a lot of a lot of space in the blockchain though? Because everyone has to have a copy of that program.
Everybody.
that's why.
Yeah, that's why that's the beauty of it. Everybody can have a copy, and of course, a small storage, compared with small storage, not gonna, store the whole blockchain, right? When I started programming for Ethereum, the mainnet was like 4 gig. Now it's like 16 gig. 8, I don't know the numbers for sure, but yeah, it's growing by the day, right? Because there's more. The community is growing. There's more applications on that, and yeah, it's just going to be growing. Yeah.
Are you saying that smart contracts or stuff that's programmed in Solidity is less susceptible to DDoS?
Is that
Less susceptible.
Yeah.
less susceptible to yeah.
Repeat the question for the live stream viewers. Yeah, are you saying that smart contracts or stuff that's programmed on Solidity are less susceptible to DDoS attacks?
Yeah, to the denial service attack. Yeah, because of this incentive mechanism that if you want to run a program on the blockchain, you have to pay money, right? And this money is in the form of a currency. That to run a program on the Ethereum blockchain is gas, right? Which is derived from ether.
How do you know how much gas is needed to execute a program?
There are handy functions that's provided by you by the blockchain that you can say, oh, this function estimate gas. So there are ways that you can do that. Okay, so we know that is a decentralized program, right? And smart contracts are coded on a programming language. Actually, you can be coded in many programming languages because the blockchain itself is what we call a Turing-complete computer. This is just a fancy word, a technical word to describe that. It's whatever language that you create, and it's able to be that language is able to be translated into a language that the computer is able to understand. This smart contract code will be run, right? So you can create your own programming language. There's going to be a smart contract, but as long as when you translate that into computer understandable language, the Ethereum virtual machine is able to understand it, right? So you could program it in in a Ruby-like language, in a Python-like language, right, Java-like language. But as long as once you compile it, the term you use is compile it, the machine, right, is able to run it, right? So the de facto language that we use now is Solidity. And the reason why is Solidity? Just because there's a community around it, right? There are people that put effort to develop it, to make it like user-friendly, like developer-friendly. So that's the reason why. It could have been some other, and there are other languages in the works. But right now, Solidity is the most used language for creating smart contracts. Any questions on that? Like, did you guys? So we are going to be using a human-friendly programming language, right? That's because humans can only understand, something, up to something. You're going to translate that into like all these, bytes and letters and numbers that the computer are going to understand. Just for you to.
Do you think we might like you have when you have take an example, high-level language you can compile to different hardware, right?
Mm-hmm.
And as we see more and more blockchains appearing, probably with different architectures of virtual machines, do you think there's going to be some kind of compiling Solidity to different
For different.
blockchain virtual machines than the Ethereum ones?
You mean like different blockchains talking to each other?
I mean, you write the same code.
Yeah.
It's smart.
Oh yeah, and then could be for Ethereum, and another one could be for Tezos. Yeah, I'm pretty sure that's possible. Yeah, yeah. If the underlying blockchain protocol is Turing complete, for sure. Yeah. So because I love hands-on approach, like let's code this thing up. Let's code a smart contract. So I want everybody to go to ethereum.github.io/browser Solidity. And this is an online editor that is very, very handy to just code up like a smart contract online and auto compiles, and you're able to debug it and all that. So just go to this website. And that's the part that I sit. And hopefully it's not going to be too boring for people that are watching that and not able to look at the screen. All right, yeah. So is everybody on the website?
No, it's low.
Yeah.
I had, autofill.
So while people are going there, I can talk a little bit more about the writings that I do for the community. So this is my Medium account. So I create articles on like setting up bounty smart contracts for like other smart contracts, right? This is like bug bounty contracts and companies that I've worked with. So yes, if you want to get into get to know what I've been doing here.
Maybe it makes sense to let everyone know that Medium in general is a very nice, actually medium to consume any sort of expertise in this field.
Yeah,
David has the Pull News or whatever channel, and he also very regularly.
Yeah. You're just saying that Medium is a great channel, great medium, right, for knowing about the blockchain space. So, and there's also, and anybody can create the account there and put blog posts. Yeah, high quality stuff.
And it gives you the number of minutes.
Yeah. So this.
For you to read an article beforehand, so you know how much there is.
Yeah. This company here called Zeppelin solutions. They create like Open Zeppelin, and it's like they are, like first-rate security, smart contract security auditors. This is some collaboration I did with them in terms of educating the community about, creating, smart contracts for the ICO, like, so that security is safe. Also, if you're based in Berlin, I got together with these guys and we created Solidity Berlin, which so Lucas and Gerhard, which actually we have a meetup coming up. About smart contracts. So we basically dissect. The next one is going to happen on August 7th in Berlin, and we basically dissect smart contracts. It's like a smart contract club, book club, if you will. We dissect the smart contracts, get the top three, like 3 smart contracts that have been hacked or used, in the last month, and we go through it. We exchange ideas, talk about how those contracts could have been made better, or like what the cool things about the smart contract is. So if you happen to be in Berlin, you're welcome to join.
Is it a monthly meetup?
Hmm?
Is it monthly?
Yeah, it's a monthly meetup. Yeah. Okay, cool. So everybody is on browser Solidity?
Yes.
Awesome. So we are going to create our first smart contract. So let's pick something simple. What do we want to build?
What are the...
Okay, here basically what you're seeing here is, this is the place where we're going to code. So this is the place where the code will be. Right? It's going to be here. Here is just like, all the settings that I don't want to talk about right now. All right. So how about we create like a piggy bank, right? Or anybody has another idea of a simple smart contract?
Let's code a contract that whenever Ether is sent to a certain address, it is diverted to my Ether address. I'm joking.
I see.
Gus, can you repeat the question, because it's really not audible when people ask questions for the people in the crowd?
Okay, yeah. So I'm just right now we're just brainstorming, like what a smart contract that we can build, right?
How about issuing back Ether or tokens for people who put it on the testnet?
So like you create tokens and then people can buy those tokens?
Yeah, or return, like, does this user match to someone that we know is valid for returning tokens?
Okay, yeah. I'm trying. I hear you, and I'm trying to maybe it would be a little bit too complex. Yeah.
An ICO smart contract.
That'll be very complex. Okay, how about like a
Let's do the piggy bank.
piggy bank? Yeah, piggy bank is very simple. Just remember, like it is. We all had that when you're kids. You had a piggy, you put some coin in, and at the end you destroy the piggy bank and get everything, right? All the coins that you had, right? So let's create a piggy bank.
Can we make it so you can't get the coins until
Sure, yeah, we can do that.
what time?
Yeah.
So you don't...
Yeah, we cannot get the coins as separate. So let's write these specs for the pig bank. So a good habit, a good practice, piggy, if I can spell it correct. Okay, a good spec is when. How can I just move this stuff? Huh. Is that we write what we're gonna. We write first in human readable, right? Writing what we're gonna do. So we're gonna create.
Gus, can you mention the address that people need to go to?
Sure. Yeah.
Because they're not all following
So how about I put this on a Slack channel?
on the community.
Yeah.
On YouTube.
That's not Slack.
It's not Slack, the YouTube live.
So YouTube. Okay. YouTube. Okay. Can you?
Or
You can maybe
can go back to the slide.
No, if you can just tell them the address, they can type it in. It's fine.
Yeah. So the address is ethereum.github.io/browser solidity. So how can maybe I can send you via Slack?
I'm posting it in the YouTube right now.
Yeah, awesome. Thank you. This is awesome, yeah. So, all right. So let's code this piggy bank. Let's write it. So what are the specifications of this piggy bank? So we can put ether in it, right? We can deposit ether. We can set a deadline for the. Actually, we can withdraw, right? We can withdraw. We can set the deadline for the withdrawal of the ether, right? What else? What else what else can we do? What are the other specifications you can think of?
Needs to be a
Minimum amount, huh?
A minimum amount, okay. That is a minimum amount. And what else? Can more than one person put
Multiple contributors?
can multiple computers be part of it?
Yeah.
Okay. So multiple contributors. Now, when you think about multiple computers, can multiple computers put this ether in this piggy bank, but only one take everything, or each person are going to take recover whatever they put? So we can. Only one person can recover. Okay. Lucky person. All right. So let's create it. All right. So here we have our specs, and it's great. You know, if you're going to become a smart contract developer, ask about the specifications first. It's or have the time to design the specification, because once you are in it, of course you are flexible to change, but it interrupts your work, right? In the middle of the process, like, we have to change everything. So it's good to spend some time, you know, thinking about the specifications of what you want to create. So first thing that we do when we start coding the Solidity contract is to pick the compiler that is going to translate. Remember the image that I showed? Translate the code that we write to the machine understandable code that you read. So the syntax for this is pragma solidity, and the latest one, I'm going to use the latest one, is 0.4.14. And here, there was other versions before it, 0.4.12, 0.4.8. These are the latest, the better, because they are fixing bugs. So it's good to use the latest.
Except if you're reading some old book.
Yeah. Right.
Incompatible
Yeah.
programs with the latest compiler.
Yeah, latest compiler. So now let's create the contract. The contract skeleton, right, if you will. Contract piggy bank, and that's it. Everything between these squiggly brackets here, like this one and this one, is what is going to be what the contract is going to be. Is it right? The contract, when you create a smart contract, it doesn't know about the outside world. It leaves its own block. If you want to know about the outside world, you have to tell it, okay, this exists. But everything inside here, it just knows what is inside that. Right? This is the scope of the. Yeah, just the scope of it. So it lives inside of here, right? All right, so now there's a special kind of function that when you deploy a smart contract, that's called only once. And this function, so when you're programming, you're creating this function. You can imagine like a black box. You put something in, and something out comes out, right? And the smart contract is a collection of these functions, right? And there's one function that is only run once, and that's when the smart contract is deployed. And this is called the constructor function. And the constructor function is the same name of the contract. So I'll show you. Constructor function. And this is function piggy bank. And this is the constructor function. It has the same name as the contract. And when you deploy, when you put this contract on a blockchain, this function is going to run. And it only runs once. And this is great to set any variables, anything that you want the contract to know, once it's live on the blockchain.
You can set up different constructors, right? And call them differently than or.
No, only this one. Yeah.
That's different than to Java or to C#.
Yeah. I don't want to get into Java and C#, but I know what you mean. Yeah. But this one just this time. Yeah.
Why is there brackets after the piggy bank?
You mean this parenthesis?
Yeah.
Please repeat the question.
So he said, why are there these parentheses after piggy bank?
Yeah.
This is a way for you to define a function, right? When you define a function, you need to give so this parenthesis opens up that you can put like things like number here. When you think about function, even in mathematics, you think that so x like f you pass g, right? So you pass something to a function, and then something comes out of it.
Yeah.
So yeah, so this is basically it. Like it comes from the idea of function in math. Yeah.
Parameters at this second.
Yeah.
Okay, cool.
Right. So now we have this everything inside this function is going to live within this scope here, these squiggly brackets. So here we have the constructor function, and we can set whatever you want to do here. So I see here that there's actually, we say that only one lucky address can withdraw.
Why is it like you can say which one has the right to
Yeah, can withdraw the ether from this finger. So here, what I'm going to do is I'm going to set the wallet, the address that's going to be able to withdraw all the ether from this piggy bank, and I'm going to say that the lucky address is going to be msg.sender. And I'm going to say the address here. So I'm going to define lucky address. So basically what I'm doing here, I'm saying that so MSG is short for message. And message, so there's two kinds of interactions in Ethereum. You can transact, right, with another wallet address. So if you have so you have a wallet address, I have a wallet address, I'm saying I'm going to send you 2 ether, so I'm transacting with you, right? I'm sending you 2 ether. That's like a transaction. But if I'm talking to a smart contract, I'm sending a message to the smart contract. So this is the difference. There's two kinds of interactions. There is a transaction, and there is a message, right? And when I first deploy this contract, I'm saying that the message sender, like the sender of this message, should be the lucky address. And
The person creating the function.
exactly, yeah. So, and I'm defining lucky address here. I'm saying the lucky address is an address, and I'm saying that when I construct this smart contract, lucky address is going to be the sender of the smart contract. In this case, it's going to be me, right? If I deploy this smart contract, my address, my Ethereum address, my wallet address is going to be the MSG.sender. If you deploy that contract, your wallet address is going to be that. So
the second time someone will contact this address, the constructor will not be run.
yeah, you will not be run. So it's going to be always, if I deploy this contract, it's going to be always me. I'm going to be the lucky address, right? Always my address.
Hey guys,
Yeah?
got 10 minutes.
Got 10 minutes. Woo, okay. So let's create the function deposit. And the function deposit is going to be, you're going to accept Ether, right? And for that, we need to put this special keyword here, modifier keyword called payable. And basically what is going to happen is that we are going to, let me put a balance here, balance. It's going to be 0 at the beginning. So basically what I'm doing here is that the balance is going to be whatever the balance was before plus msg.value, right? The message value.
The balance, the way you set it up, it's supposed to be unit balance? Or?
Yeah. uint is unassigned integer. It's very
Okay.
technical term, but for what you can imagine is like it's an integer, it's a number, right?
What if the msg.value is a negative? Can it be, no?
You cannot send a negative ether, right?
Okay.
Yeah.
Do you have to worry about like floats or doubles?
That's a very good question.
Say again?
Floats, yeah. So how do you deal with floats and doubles in and floats is just decimals, right? Decimals. So this is a good question, and Solidity doesn't deal with that per se. But when you send ether to a contract, or when you send a transaction, you don't send ether. You send actually Wei, which is like
The highest precision of ether, right?
yeah. So it's like 0 to the negative 18, right? Yeah, you send ether. So when you send Wei, it just gets
Multiples of that.
yeah.
I think also because you have the same with the dates that are presented in or signed in as well.
Yeah, so when you send ether, if you send one ether, you're actually sending 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So you're actually sending this. You're sending 8 Wei, this number in Wei. And Wei is just like a value, a representation of ether, right? Okay, so here we are depositing, and it's going to be balance is going to be, you're just adding it up, right? Adding up. And now we can create another function called withdraw, right? Withdraw. And withdraw, we can say that lucky address dot transfer balance. Lucky address or transfer balance.
Payable, what is the keyword for?
So payable is just like a modifier, like a keyword that was added. You see here how I put like pragma solidity 0.4. So before you could send ether to any function, and the folks that were creating Solidity realized, oh, this is not a good idea. Let's just like whitelist. Let's just add a keyword that people can whitelist. What are the functions that can actually accept Ether? Yeah, and that's why now if a function accepts, Ether, you have to put payable in it. Okay, so right now we created basically like this. We fleshed it out. Now let's add the detail about this contract. So here we can deposit Ether, right? So we did that. We can deposit. We can withdraw, right? We can withdraw. We can set a deadline for the withdrawal. Okay, that's a good one. Let's set a deadline. So here we can say uint is deadline. Right, deadline. And here on the constructor, what is the deadline you want to set? When can this person
A year.
A year, okay. So deadline equals now plus 1 years. And then here we can say withdraw. We can say require now be more than deadline. Okay. So we did this, right? You can set a deadline for the withdrawal. Sure. So we did this as specification. Now let's do the other one. There is a minimum amount. Minimum amount. Okay. What is the minimum amount?
10,000.
10,000 Ether?
I think small units, like a tenth of an ether. Well, no, maybe half an ether.
Okay, so this is the minimum amount that you can deposit. Okay.
You don't want to mess around with small ones.
Okay.
Yeah, the big game here.
So how about you can deposit, the minimum amount is only like 1 Ether, right? Yeah. So here for the deposit function, we can say require that the msg.value, right, the value that you're sending, should be more or equals than 1 Ether. Right?
So these functions will just exceed or the line will just exceed the function when this condition is met?
Yeah, if this condition is actually this require, it was added, in a new compiler, one of the new compilers of Solidity, and this is basically an if clause. So it says if message dot value is less or equals than 1 Ether, throw. And this throw just means that revert to the state that that this contract was before this function was called. You just revert to where it was. You just throw it. You throw an error. Say, oops, you cannot do it.
Basically, if someone sends now a transaction with 0.5 Ether, he will waste the gas.
He'll just waste the gas, but he'll get the Ether back, right? The 0.5 back.
Yeah.
So this require is basically this if clause. So they just created like this sugar, like synthetic sugar, to make it more readable, right?
What is the warning sign on the left of
Here? Yeah, this is just about now. I use now here, and it's basically saying that remember that now is block dot timestamp. It's the same thing, right? Yeah, block dot timestamp. That's basically it. Yeah, it's just like just so that we are aware.
What if you want to set a specific date? Can you do that, or is it always at a change?
You can do, but yeah, it would be like in timestamp. In timestamp, yeah. Like the result of this is just timestamp. Yeah.
And that's from when you put it on the blockchain.
Yeah. Cool. Okay, so now let's see. There's a minimum amount, multiple contributors. Yeah, actually, we can. Anybody can call this function, right? We're not setting any restriction there. Anybody can call the deposit function, so this is good. And there's only one lucky address that can withdraw it, which is the address that I own if I deposit something. Cool. So this is the piggy bank smart contract. And then here in browser Solidity, you can create it. So this is just like a test environment, right? So you're not actually deploying to the blockchain. So here we can create it. And then you see the transaction. You see that the transaction costed 181,266 gas, right? And then the execution cost was 103,850 gas.
High value, no?
Yeah. But it's cheap, huh?
I've got red X next to line 11. So this browser piggy bank parser error expected token L-Grace contract piggy bank.
Yeah, I'm having a contract with piggy bank one. Give me errors.
So it's giving me an error down there. I can't create.
Interesting. Can you bring it close?
Where's this analysis about the cost?
Okay, I hear it. Because this is piggy bank is together.
But I named it different there, so I'll just follow what I did there.
There you go. And delete this one. There you go. Great.
Yeah, nice.
Yeah, so one thing that you realize that this is very, very picky, right? This compiler is very picky. If you make any mistake, and like if you forget about the one semicolon, or if you misspell it, it will complain. It will scream at you. Yeah.
I'm having a similar thing with uint balance equals 0.
Yeah. So.
We'll debug after.
Sure, yeah. So here now we can, you see these buttons here, so you can call deposit, you can call withdraw. So let's call deposit with, if I call deposit with 0.5, right, in value, it exploded, you see, exception during execution, invalid. And the reason why is because we have this line here, that it requires the value to be more or equal than 1 ether. So let's call it again with 2 ether. Let's call deposit again. Where's deposit? Here. If I call deposit again, boom, we have it. We have ether in that. And then we can withdraw. We can continue. I can change another to another address here. Sure. I'll be with you shortly. I'm just going to finish this up, and then I'll be with you shortly. So now I can, here we can pick another wallet address, and then you can 10 and send it. You deposit, and here at the bottom here, wow, another deposit. And let's withdraw. If I withdraw, if I click withdraw now, what's going to happen?
It's going to say not 1 year. It's not going to execute.
Exactly, it's not going to execute. And boom, it's not executing. It's not only going to execute now from 1 year, right? Because in this withdraw function, we have this constriction here, restriction. Require that now should be more than the deadline. And the deadline we set at the constructor function.
Yes, but if that condition will be met, what will be the logic to withdraw?
So if you want to withdraw, we need to wait 1 year from the moment that we deploy the contract.
But who will get it if multiple people will send
Is lucky address. And lucky address, if I launch the... Oh.
You have to press stop. You have to press the stop button.
I have to press stop? Okay, cool. Thanks. If I... Oh man, it's not... Okay, so I have to redeploy it. So the lucky address, so I'm deployed it, launch debugger. So solidity state. So if I, okay, so the lucky address is this address here.
This one here doesn't exist. The second one.
Balance is 0, deadline is 0.
Because lucky address is set on
Yeah,
the initials.
yeah, initial. Whoever deployed that contract. And if I deploy it with 2, 4,
The debug feature.
and then you debug it. So let's see the local state, solidity state. Okay, the balance is 4, and the deadline is this timestamp here. Boom.
January the 1st, 1970, since the number of seconds.
Yeah. Timestamp is just like from 1970. Yeah, like in numbers.
What if I want to change the contract? I want to change the deadline to be today.
You can do that, but just remember, this is like a testing environment, so you could do that, right? But once you deploy the contract on the blockchain, you cannot change it. It lives there.
It's very important to understand.
Yeah. It's important to understand that once you deploy this contract on the actual Ethereum blockchain, you cannot change it.
And you can create a new version of it.
If you want to change it, you have to go back to your code, change whatever you want to code, and then create a new contract, right? Like a new one.
But
the older one still exists.
The old one is still going to be there forever.
And so would you have to, can you like nullify that one?
What we can do, we can create a function called, let's call it destroy it. Destroy it, right? And then here we can say self-destruct. And then you do lucky address. Actually, I'm only putting lucky address here because this self-destruct means that it destroys the contract and sends all the balance to one address, right? And here I put lucky address. Because if I want to destroy it, you'll destroy it and send whatever is left over in Ether to lucky address.
But this is dangerous.
To destroy a contract? Only if you know that this contract is, people are using it.
Okay.
But if this contract, you find out that there's a bug in this contract, and oh man, like this is being hacked, and people are losing money. So this is actually very good to have, because then you can just destroy this contract, and then you receive the whatever funds were in the contract, and then you can create another contract.
How do you destroy it?
So here say that I deployed, right? And I have here the function destroy, right? And I just call it. Now it's destroyed.
So do you go to the same page after it's on the blockchain? And you can
It would mainly be like, you can create like a GUI that's like this, that you can do it, or you can create a code that we call deposit, that you call destroy, right?
When you destroy it, can you call it again?
No. So if I try to deposit, it doesn't allow me.
But the code is still in the blockchain.
No, it's actually it now is just like a 0. Like the address is like 0.
So hash exists.
Yeah, but yeah, there's no code that to run. Yeah.
Even through the code itself will be stored somewhere.
Yeah, but you cannot transact with it.
in the old blocks, right? So the block right before you destroy
Yeah. The block before will have the code, but from that block on, we'll not have the code. So this is it. Hopefully, So I hope to meet you in a few months in Berlin or somewhere else, and we can create another smart contract together. Huh?
Where are you located?
In Berlin, Germany. Yeah.
I'm going to try to change my flight because I want to meet the programmers in Berlin.
Awesome. Yeah. So we are there. Cool. So now I can debug. Ask questions for debugging and all. You got it? Okay. Cool. Yeah.
Well, I got it.
Sure.
I got mine. I wasn't keeping up because I was going back and
Sure,
forth
sure.
watching you. I don't even think I got all the lines in. I think.
So let's see what is missing. So piggy bank, that seems correct. Yeah, that's correct.
There was one other.
Okay, so what is different between this, how lucky address is typed here, and how lucky address is typed there? There's a difference. Look at the details. Yeah. So
Yeah, I was back and forth.
and there's still a difference. You know, remember this compiler is very finicky. Like it needs to be the exact the same. Even the case needs to be the same. So there's one thing. Find the difference.
Let's see. Well, if I had my mouse, I wouldn't even worry about it. I would just copy.
Yeah. But okay, so here, you see, yeah, the big L and the L, yeah. So that's basically that was the reason, and then same thing here.
I never trust my own typing.
and we all susceptible for that. Yeah, there you go. This is. And then actually now,
I think I added all the requirements.
Yeah, the requirements would be, so this would be an equal, right? Because you are setting this to message as value. And the require here would be the minimum amount, right? So you say require. And then you open parentheses.
Like so.
And